Hello, welcome to my presentation. For today, I will be discussing about alpha particles, beta plus decay, beta minus decay, electron interaction with matter, and X-ray interaction with matter. So for our first topic, we will be discussing about alpha decay or alpha particles. So first, what is alpha particles? Alpha decay is a nuclear decay process where an unstable nucleus changes to another element by shooting out a particle composed of two protons and two neutrons. Alpha decay usually occurs when a nucleus is unstable because it has too many protons or has an atomic number 90 and above. What are the effects in alpha decay? In alpha decay, the process of it is where atom release two proton and two neutron from the nucleus. Its atomic number decrease 2, while its atomic mass number decrease 4. The particle emitted from the alpha decay is called the alpha particles. The energy emitted produces gamma rays, and the charge of alpha decay loses 2. So for our next topic, we're going to discuss what is beta decay and what is beta plus decay. Beta decay was named in 1899 by Ernest Rutherford when he observed that radioactivity was not a simple phenomenon. Beta decay occurs when a nucleus with too many protons or too many neutrons. One of the protons and neutrons is transformed into the other. In beta plus decay, which is also known as positron emission, which means atoms are lacking of neutron and proton be converted into neutron. As in positron emission, the nuclear positive charge and hence the atomic number decreases by 1 unit, and the mass number remains the same. Remember that lost electron has a high energy called beta particles. What are the effects in beta plus decay? In beta plus decay, its process is to turn proton to neutron. The atomic number in beta plus decay decreases 1, while the atomic mass number stays 0. The particle emitted is positron and neutron. The energy emitted produces annihilation radiation, and the charge in beta plus decay loses one positive charge. After beta plus decay, let's move on with beta minus decay. What is beta minus decay? In beta minus decay, beta decay also occur when a nucleus has too many proton or too many neutron. Just like what beta plus decay do, beta decay, beta minus decay also turn neutron into protons. In beta plus decay, its process is to turn neutron to protons, while the atomic number in beta minus decay is increased by 1, while atomic mass number remains 0. The particle emitted from the beta minus decay are the negatron and antineutron. Energy emitted produces none, and the charge in beta minus decay gains one positive charge. Let's proceed with electron interaction with matter. In electrons, we have neutrons and protons. A certain interaction of the incident electron with the sample is obviously necessary since without the generation of a signal, no sample properties are measurable. Electron interaction with matter, as we all know that electron plays a big role sa bawat elements natin. So dito po sa topic natin, we will be discussing kung ano nga ba yung mga role ng protons and neutrons natin in regards to this topic. So just like what I've said, there are two different types of interaction that we will be discussing later. In electron interaction, in elastic interaction, in this case, no energy is transferred from the electron to the sample. In inelastic interaction, a collision between bodies in which part of their kinetic energy is transferred to another form of energy, tending to result in the slowing or joining together of the bodies. So dito naman po sa inelastic interaction, meron daw pong banggaan na nagaganap in where um, the energy of one atom interact with another atom which cause them to bounce or to scatter. Next, X-ray interaction with matter. In X-ray interaction with matter, the intensity of an X-ray beam is reduced by interaction with the matter it encounters. The X-ray photons are either absorbed or scattered out the beam. In scattering, protons or photons are ejected out of the primary beam as a result of interaction with the orbital electron or of absorber atoms. The atom produced can also affect the kVp and MAS of the X-ray. How does kVp and MAS affect? It is because kVp, also known as the energy of the X-ray or how strong the photons are, while MAS are the quantity of how many protons can be produced in X-rays. Coherent scattering. Coherent scattering, also known as unmodified classical or elastic scattering. It is one of the three forms of photon interaction with which occurs when the energy of the X-ray or gamma photons is small in relation to the ionization energy of the atom. It therefore occurs with low energy radiation. What happened in coherent scattering? In coherent scattering, the X-ray travels to the orbital shell and changes direction, which causes scattered radiation. Compton scattering. Compton scattering was discovered by Arthur Holly Compton. It is the scattering of a photon after an interaction with a charged particle, usually an electron. If it results in a decrease in energy of the photon, it is called Compton effect. What happened in Compton scattering? In Compton scattering, the X-ray bounces into one atom and bounces also, which form scattered radiation. Photoelectric effect. Photoelectric effect is the emission of electrons when electromagnetic radiation, such as light, hits a material. Electrons emitted in this manner are called photoelectrons. What happened in photoelectric effect? In photoelectric effect, the incident photon is completely absorbed in the process. The photoelectric effect contributes to the attenuation of the X-ray beam as it passes through matter. The electron that is removed is then called photoelectrons. Pair production. Pair production is a process in which a gamma ray of sufficient energy is converted into electron and a positron. What happened in pair production? In pair production, the X-ray travels into the nucleus, and the nucleus releases two electrons, which are one negative and the other positive, which called positron. In photodisintegration, also called as phototransmutation, in physics, nuclear reaction in which the absorption of high-energy electromagnetic radiation or a gamma-ray photon causes the absorbing nucleus to change to another species by ejecting a subatomic particle such as a proton, neutron, or alpha particles. What happened in photodisintegration? In photodisintegration, the X-ray photon is captured by the nucleus of an atom with the ejection of a particle from the nucleus when all the energy of the X-ray is given to the nucleus. That would be all for my presentation. Thank you for listening and have a blessed Merry Christmas and a Happy New Year.